All right, now I'm streaming. And so we're going to chapter 20 in the textbook, uh, page 20-2, and we're going to go through that first exercise. So the first thing is we're going to open up, um, so actually in Canvas on the home page, if you haven't all already downloaded it, there's this SolidWorks Basics book files, and that's just a folder of all the exercise files that come with the book. So you can just download that right from that link there. And then once you have that, you're gonna go into that folder, and it's broken down by chapters. You're gonna go to chapter 20, and then it's this first part, design table, and you're gonna go ahead and open that. And I have it open here. So, and then once you open it, it's going to be an older version file. It's going to be like a 2015 version file. So just go ahead and save as, um, and it'll update it to the SolidWorks software version that you have installed on your computer. So I'm going to go ahead and just put it on my desktop. Oh, and I already did that, so I'm going to replace it. Yes. Okay. So once you have it saved, you can it just makes it easier because it's the version that you have, so there won't be any weird bugs, hopefully. Um so your first step is you're going to go to the view, you're going to add you're going to enable dimension names. So all of these dimensions in this file that they provided are named. So it's just going to make this exercise a little easier. So you're going to go view, and then you're going to go hide and show, and you're going to select D1 dimension names here. So you're going to go ahead and click that, and they'll all show up over here. So it's going to show you upper diameter, side step here, height, dimension. So you know, once you have your design table, you know which dimensions you're looking at in the table. It's not just a bunch of numbers. So and that's a good idea. It's a good practice in general when you're creating parts, to name your dimensions, just so that when you have your design table open, you know what they are. And you can do that right up here. If you double click on the dimension to edit, and you can type in the dimension name right here. So, and that's all there is to that. So, um, so now we're going to create a new design table. So we're going to go insert, and then we're going to go to tables down at the bottom here, and we're going to go to design table. And once we click on that, it's going to open up this menu on the side. So what we want, the book is telling us to select blank for our source. And then allow model edits to update the design table. So say you go in here and you change this dimension right here, it's going to change it in the design table as well. So you don't have to worry about it. If you were to select this option, you wouldn't actually be able to change your dimensions in here. You would have to go into the design table to change them. And that can be helpful if you don't, if you don't want to like break your part by mistake by going in and changing dimensions. But for this exercise, I want us to select that first option. And then for these options, they want us to check all three except for this last one. So enable cell drop down lists. That just is basically in Excel, you would be able to like click the cell, and then there would be a drop down menu to add values in instead of typing the values in manually. I guess it just slows it down a lot, so we're just not going to use that for this. But the other three options you do want selected here. We're going to click OK. And now we have our table. Well, okay, asks us to do a couple other things here. So, um, please select the items you want to add to the design table. You don't actually need to do anything in here. It's showing all of these, but you're going to add those in manually after. So you could select all of them here, but we're not going to do that. We're going to click OK. And our table should show up. What's going on? Okay, the table should show up right here, but it's not. I'm having a problem. Okay. I did, in fact, click OK, didn't I? I'm not sure why it's not showing up. So, let's see if it's back here somewhere. No. Oh, there it is. Okay. I guess it was just some kind of SolidWorks bug. All right. So, and cell B2 is selected by default. So the next step is we're going to transfer each dimension over to the Excel worksheet by basically we just double click on them. So the dimension description is going to be kind of your column heading for each dimension, and then it's going to put the number in underneath. So they tell us what order they want us to add them in. So I guess we're going to start with, what are we going to start with? The height dimension 2.75. So this one right here. So when you double click on it, it's going to show up right here. The name will be in row 2, and then the first instance of that dimension, the first basically the first value is going to be in the third row. So we're going to go through and do that for each dimension. And it says repeat the same step and transfer the other dimensions in the order as shown. So what we're going to do next is we're going to select each of these dimensions in the order they show in the book. So upper diameter, which is 4, is the next one. And then lower diameter. And then we want side radius. And that's all of our dimensions. So, and you can expand this a little so you can see all of them. I guess I have to expand it more than that. There we go. Okay. So, now we're going to use Excel's addition formula. So if you're super familiar with Excel, this is going to be pretty obvious. But if not, basically in Excel, you can use formulas to kind of add values automatically. So we're going to select this next cell underneath, and we're going to say what's in this cell is going to equal what's in B3, so the cell right above it, plus 0.125. So the way we do that is we just do equals, we click this cell, and it automatically puts it in there. And then we say plus 0.125, enter. And it's going to do the math for us. So you're going to see the result of your equation right here. If you click on it, then up here you can actually see the formula. And we're going to do that for each one. They want different, well, okay. I guess over here they want us to call them, they want size 1, And then they want all of those down to size 9. Let's see if this works. Okay, so another thing, if you're familiar with Excel, you'll know this, but if you drag the corner of a box down, it's going to copy that box all the way down. Now, if it's numbers, it's going to count up. So if you grab this corner and you drag it down, it's going to count the numbers up from the one you started with. And so if I wanted to add another one here, I would just drag it down. It would copy the text and add one to the number. So little Excel trick there. So they want this formula dragged all the way down as well. And the way formulas populate is it's going to be the same formula as this box, but instead of B3, it's going to be B4 plus the same number. So, and so on down the line. So you're going to count up in increments of 0.125. So I'm sorry, can you say that again? Oh boy, I don't know what you pressed. So mine like kind of just disappeared on me for a second, and I just minimized SolidWorks and opened it back up and it showed up for me. But yeah, I'm not really sure why it disappeared, so did you click OK over here? All right. Yeah, if you exit out of your um gosh, I'm sorry, my dog is barking. I don't know if you can all hear him. But yeah, if you exit out of it by mistake, you can get back to it. So let's see. I click OK here. You found it? Okay, cool. All right, I was gonna try and get out and go back in to show you, but if everyone's good, then I won't worry about it. Sorry, 1 second. All right, sorry about that. I was just trying to get my puppy to calm down. Um, all right, so the next column they want us to, I guess they want us to do the same. They want us to add the same number. So these are going to change in this exercise. It's not all going to be the same formula, but for this one, it's going to be the same. So we can just drag it over, and it should be C3 plus 1.25, and then we're going to copy that down for 9 instances. This one, they want a different formula. It's going to be let's see, D3 plus 0.0625. So we're going to go equals D3 all right. So that's column D. And then for column E, they want 0.0625 added for each instance again. So we're going to, again, just copy that formula over to the right. Make sure that this up here did what you wanted it to do. Sometimes, I mean, Excel usually is pretty good about this stuff, but every once in a while you don't get the result you want. So always check here and make sure that the formula is actually what you want it to be. because one bad formula in a big spreadsheet can completely mess you up and it'll take you hours to find it sometimes. So, all right, we're just going to drag that down. And then they want, for the next three, they want plus 0.03125. Or for the next column rather. So we're gonna do point 0.03125. And then we're gonna copy that down to F11. And then for column G, it's gonna be plus 0.02. So now we have a table full of different values for our dimensions. And what we can do here is we can use each row in this file, in this spreadsheet, to change all the dimensions in our part. So there's one more thing that we're going to do before we leave, which is we're going to add the cut extrude 1. So we have to double click it. There we go. And then it automatically filled in unsuppressed. So we're going to replace that with just the letter U, which indicates unsuppressed. That's what the book tells us to do. And then we're going to alternate all the way down. So we're going to do suppressed, unsuppressed, suppressed, unsuppressed, and so on and so forth. Not yet, so we're gonna get there. And then so we can exit. Bo, stop, please. Sorry. We can exit. The UPS truck is here, and everybody's all up in arms about it. Buddy, here. Go on, go get him, bud. All right. At least if he's not in the room, he's not quite as loud. So, he's actually going to the house across the street. He's not even coming here, so my dogs are a little paranoid. But okay, so it's telling us next, we're just gonna exit this spreadsheet. We're just gonna click outside of it somewhere. So we have these configurations that were generated. We have 9 of them. If you remember, we had 9 rows, each with a different dimension. And so now we have 9 configurations of this part that we can use. So we're going to go ahead and click OK. Haku is chapter 20. All right. So now we have 9. No worries. We have 9 configurations, and you can see them all here. So they named them size 1, size 2, just like we named them in our spreadsheet. So it's really cool. It just automatically generates the stuff for you just because, just by putting values into a spreadsheet. And then you can use any of these configurations. You can change, basically, let's see. Is it actually doing it? Yeah, so it changes all your dimensions if you just double click a different configuration. Mm-hmm. Yeah, so basically you can just like do minus whatever you want to account for the expansion of your plastic. Um, you can add in each dimension, and then for, configuration number 2, just do uh, whatever is in the row above minus, you know, uh 2 thousandths, or I don't know what it is. It depends on the printer, but um yeah, and you can use that to so you design your part with the actual dimensions you want, and then you print a configuration customized to the printer you're using. So, and then you can also, you don't have to use your design table to change every dimension. So you can go into your table. I think this is where I open it. Hopefully it opens. Yeah. Yeah. So like you could do another here where you say, let's just add one for kicks. We're going to do size 10, and we're going to go, everything is going to equal our original size 1. So we just drag that all the way across. Let's see. And I guess we'll make it unsuppressed because that's what's in the first one. And then we just want to say, okay, I want everything the same, but I want this to be 2.45 instead of 2.5. And that's that radius, I guess. We'll see if it breaks it. I don't know. But so now we just exit, and it generated another configuration for us, which shows up here. They go, it's kind of weird how they're ordered. It's going to order them if you do double digits. It's still going to order it by the first digit. So you could do size 0, 1, 0, 2, 0, 3, 0, 4, and then 10 would be at the end. But I'm not going to bother with that right now. So there's our 10, and that radius is 2.45 instead of 2.5. So, and the cool thing about this is that when you have all your configurations, if you change something and you're like, that's not going to work, I want to change it back, you can just go back to the original one. Oops, that's not what I meant to do. Show configuration, there we go. So, yeah. You can, you can, uh, you can definitely do that. Your dimensions, Eduardo asked, can we use the Excel spreadsheet across different parts? Your dimensions are going to have to match though. So like if I were to copy this spreadsheet onto a different part that had different dimensions, they wouldn't all match up. Does that make sense? So it would only work if all your dimensions match up. You can also do design tables with an assembly. So in that scenario, you would have let's see. I'm looking at the book. It talks about it on the next couple of pages. So for an assembly, you can suppress or show different parts in your design table. You can add in dimensions there that you want to have, but again, each column in the design table relates to one dimension. that you have. So yeah, you have to make sure that those links aren't broken. You can you want to change only one dimension and have that math with another part. Have it match with another part? Yeah, you can do that. Mm, I'm not 100% clear on what you're asking. I think you can, yeah. I mean, you can create different parts and all the dimensions have the same names, or any of the dimensions you want to give the same names to will have the same names. So, yeah, you can definitely do that. You can like have two parts and they um you can like copy the design table from one into the other so that like you can make changes. So like that instance one of this part is going to match instance one of the other part and so on. Like you can have corresponding values in the two tables. But I'm pretty sure you have to have, because the design table is in the part file, so you can't like have one that's outside the part file that relates to both. Does that kind of make sense? At least I don't think there's a way to do that. If somebody comes up with one, then okay, cool. Yeah, if there is a way to do that, I don't know about it. So, um, but yeah, I think you have to have a separate design table for every part that you create. Any other questions? Haku is typing. I'm just waiting. Okay. All right, cool. Um all right. So let's see. If everybody's open to it, we could continue and look at the assembly design table, which is the next part of the chapter. Could just continue on because that went pretty quickly. Um no objections? Okay, cool. Let's go for it. So, and I haven't recently read through this, so bear with me, but we're going to go back to the training files folder. Um, so in the chapter 20 folder of that folder, and then the let's see, egg beater assembly folder. Is that okay? That's this one. It doesn't call it egg beater assembly, so I'm gonna copy on my desktop and I'm just gonna paste it there. All right. So we need to copy and paste it so that we have all of those part files actually saved. And actually, this is going to be annoying. I think we have to save them all as the latest version so that when we open the assembly, it'll actually work. So I'm going to go through real quick and do that. I think I can actually just go save. Yeah, you don't have to do save as. Makes it a little quicker. I'm just closing them back up so it doesn't. I'll go ahead and save that so it doesn't slow down my computer too much. All right. My computer at home actually is faster than the one at school, believe it or not. So it's kind of nice to use for class. Okay, and there's the assembly. I think I missed a couple of parts though. Not that. Eduardo, so to reopen the Excel and edit, go to your configurations and it should show up at the top. It should show the spreadsheet, and if you right click, it gives you the option to edit. I'm not sure if this is actually necessary because everything seems to be showing up, but all right. There's a handle. Okay. So we've got the assembly open. So we're going to use the state and configuration parameters in a design table. So let's see if I can remember what that means. So we're going to insert a design table. So we're going to go to tables and then design table, same as we did for the part. Eduardo, were you able to figure out the how to find the Excel file again? Okay, so if you go to your configuration manager tree here on the left, it'll show up. If you click that, it'll show up in there, and then you'll be able to. You can't even close the SolidWorks. Is it frozen or is it just not doing what you want it to do? Is there something else wrong? Okay. Yeah. Well, that's technically what the lab is for. Yeah. Mm. So Eduardo, if you right click, did you right click on it? Mm. Hmm. Okay. Hang on 1 second. Oops. See if I can find my last funnel thing I was just working on again, so I can. one? Oh, dang. All right. So if you go to your feature manager's tree and you click the arrow, the down arrow by tables, and then you right click here, you can go edit table. Do you see that? Hmm. All right. And you're not right clicking here. You're right clicking on the you expanded the little down arrow here and you're right clicking on the actual table. Mm. Hmm. Yeah, that might be your best bet there is just starting over. Oh, I know. I'm sorry. Yeah. Yeah, no, it's a pain. By start over, I mean just reopen the file. um, I hope I'm not. Yeah, it does. Mhm. Yeah. Mhm. Yeah, that's correct. Oh, good question. I yeah. Mm. um, yeah, I think yeah, I think that sounds right. I'm honestly not really positive about how it works. I know like um well, I'm pretty sure you don't actually have to have Excel installed on your computer to use the feature. I'm sorry, I'm getting a weird tickle in my throat. Yeah. Yeah, it's like a file within the SolidWorks. Yeah. All right, so let's try and continue on here. I'm trying not to like start coughing because I like just needed to drink a bunch of water and my throat is all dry. All right. So we're gonna do a new design table. So that's where I was. So we're just gonna go insert tables, design table, and then we're gonna select blank for the source. Um, Under edit control, we want the first option selected again. And then under options, we just want to unselect that last one. So the other three should be selected. And then, let's see. I think that's all. Then we click OK. So then the blank design table is going to show up. And so the book says here, I don't know if this adds more confusion to everything, but it says at this step, a blank design table will appear and overlay the SolidWorks screen. The Microsoft Excel application is running side by side with SolidWorks. And I guess that doesn't actually answer the question of, is it actually Excel on its own that's running on your computer, or do you have do you have like an instance of Excel that's embedded in the SolidWorks software somehow? I'm not sure, but anyway. So, yeah. Hmm. Oh, there goes my little dude again. There's literally nothing even happening now. I can see out the front window and there is literally nobody out there. He's a little goofball. All right. Okay, so we're gonna click OK here, and then our design table should pop up. There we go. I guess there's some weird bug. I just have to like minimize and reopen for it to show up, and I like to make it a little bit bigger so I can see what I'm doing. So let's see. It's saying click the alignment tab and set the orientation to 90 degrees. I'm trying to remember what the okay. So you can do that by going into formats. So that took me a second. I haven't used Excel in a while. So go to format, right click, go to format cells right here, and then click the alignment tab. The book doesn't really walk you through that very well, but I think they just assume that you kind of know what you're doing. So you're going to rotate your text to 90 degrees. So just drag this red diamond here up to the top. So your text is rotated to 90 degrees, or you can just type 90 into this little box here. All right, and I'm not really sure why they want us to do that other than for looks, but we'll go with it. Oh, I guess it does tell us. I just skipped a step. So the book says right click the row number 2 arrow. So you're going to actually right click on the 2 here. You only want to format row 2 that way. Everything else you're leaving alone. So then you're going to define the column headers. So we're going to copy the name of each component and paste it into the design table. Those will be used as the column headers. So So that means we go over here and we have all our components of our assembly here. So we're going to right click. Oh. It didn't really work the way I wanted it to. I'm going to right click the name of that component. We're going to go over to component properties right here. And we're going to select that. We're going to go to full name. I'm going to right click. This seems like a more efficient, there's got to be a more efficient way to do this, but so select all and copy. Now we're going to go back to our table. Right click and edit table. And we're going to copy that into cell B2. And then you can mouse over the bottom of that row so that you have this little double arrow thing that I have here, and just double click to expand the row so that you can see the whole name. And you're going to repeat that sort of clunky process for all the components, I guess. So we'll have to go back to our tree. Right click the main gear. Go to component properties. Select all. Copy. Go back to the configuration tree. Edit your design table. And, I guess that's an invalid feature name. I'm not sure why. Okay, whatever. We're gonna paste. Okay. Is everyone still kind of following? All right, I'm gonna take that as a yes. So, all right. So I guess we just have to go through this whole thing and do it their way, which is silly and annoying, but I feel like there's got to be a more efficient way to do this. Yeah. Right. That always gets the point across. So I think the other thing too is this might just be something that like an older, I don't know, an older version of SolidWorks like this worked better. Maybe, I don't know. Just because I have the 2019 book and we're using an assembly file from the 2015 folder. So I'm kind of wondering, like, has something changed? I don't know, but Haku, did you lose us? Is everyone else still able to hear me? Okay. Cool. All right. Hopefully, he's able to get his sound back. All right. Oh, nice. All right. Yeah. That would be nice. Well, if you decide to go over the video later, you can skip this really boring part where I use this inefficient method of copying all these names in. So, you can just fast forward this part. True. All right, left spinner. Got 3 things left. Oh my goodness. People always make fun of people who have yappy, obnoxious little dogs. And as I don't know, one day I woke up and I realized I am that person now. Yeah. I've got 3 actually. The one that is yapping is the old one. He's old and grouchy and thinks he's in charge of everything. And the other 2 are puppies pretty much. One of them is about 2 and the other one is a 8-month-old golden retriever. Um and they're a handful, but they're worth it. They're pretty silly though. All right, I think that's everything. About 1, 2, 3, 4, 5. Got 8. Yeah, I think that's it. Okay, so now, the step 5. For cells B2 through H2, insert the header state before the name of each component. So it's $state at symbol. So we're gonna go in here. We're gonna go. Just copy that. Paste it at the beginning of each one. Oh my gosh. All right. So for cell I2, insert the header $configuration at. Okay. So instead of no, I don't want to open the link. I want to let's just do edit hyperlink. I don't know if this matters. But we'll just go ahead and do that. All right. So the configuration names, we're going to do default and then this one we're just going to drag it down so there's 6 configs. All right. And then the control values, they want us to type the letters R and S into each cell as they show in the book. So, let's see. It looks like the first column is all R, so we'll just go ahead and do R, and then we'll drag that down. The next column, we've got all R's except for one S in config 1. So let's just do this. And then, because it's R's all across the top, we've got S here, and that goes all the way across. Okay. So it looks like there's sort of just there's a pattern here. Oops. Okay. So, okay, it's R all across the bottom row as well. So we'll just copy that over. Just trying to make sure I actually get this right because the book says to prevent mistakes, type in each letter, and I'm like, I'm not going to do that. So in this row, there's 3. Yeah, and I guess there's nothing in the last column yet. Okay. All right, if everyone's still awake, the last column is going to be default in the first row, and then oval handle in the second, and let's see if we can get these alternating all the way down. Yeah. All right, cool. So, it looks like now we can just use this. So, so the book doesn't do a really great job of explaining what's going on in this table, but basically, each column is the state of one of the parts. So, the crank handle part is always visible, so it's never suppressed. So instead of defining the state, they define the configuration. I guess the crank handle part has two configurations, and these are the names of them. So depending on which assembly configuration you choose, hopefully this makes sense. Depending on which assembly configuration you choose, um, a different crank handle configuration, part configuration will show up, whichever one is in that row of the spreadsheet. And then the R, I think, just means I can't seem to think of what R stands for, but it means that part is showing in this configuration. If it's an S, it means that part is suppressed. So we're going to go ahead and close this. And now we should be able to go to our configurations, and we'll have these 6 that were created. Okay, so let's see. Let's try configuration 6. Most of the parts are suppressed. So let's see what that one looks like. Show configuration. I don't know if it worked. Okay, yeah, maybe I had it backwards. Okay, so most of them are suppressed in the first configuration. None of them are suppressed in the 6th. So does that make sense? So you can use a design table to do different configurations of your assembly. Is that kind of making sense to everybody? Cool. All right. So, oh, I see. It does say. So R stands for resolved and S stands for suppressed. So let's see. It seems like it's backwards though, because when I looked at configuration 1, it looked like everything was suppressed. And if you look at the table, it looks like everything is resolved there. So I'm not sure what that means, but let's go to default. So everything will show up here. Yeah, I'm not sure. It might just be backwards. It doesn't matter that much. Anyway, the point is that you can use that to play around with your assemblies and like hide or show parts. Basically, this design tables are a really quick way to make a bunch of configurations. And it removes a lot of room for error, because when you enter everything into the design table, you've got everything there in front of you in the table. Like, there's less opportunity for you to, mess up a cell or something, because you can see everything all at once. Makes it a little easier than manually editing a part, basically. So. All right. So, that's I think that's all the exercises that we'll go through today. I hope everyone got a kick out of that. So for next week, we're actually really getting down to the wire, unfortunately. I kind of realized we only really have 2 weeks left. So you have 2 more parts to design and turn in for your machine. And I know some of you are kind of a little ahead. Some of you, are still, just keeping up. But I don't know if anyone's behind. Nobody's behind on assignments. I think it's been hard to 3D print things because of the situation that we have. So I want to really make sure everybody's got time to print their stuff. And I know that's going to be tricky. So if you have anything that you need printed and you know that you won't be able to get it printed in time, uh, go ahead and send it to me, and I'll try to go to the lab as often as I can and print things for people. The caveat to that being that if somebody is there printing something in the lab, I can't just kick them out of the printer, right? Like, so if you ask me to print something for you, I'll do my best, but um, I can definitely do stuff on the weekends because I'd be the only one there. But if it's during the week, what's that? Exactly. Um, so if it's during the week, I might not be able to print your parts for you just because other people are going to be there printing too. But I'll definitely the next couple of weekends try and spend some time there and get as much done as I can. So if you need stuff printed, send it to me. And if you're able to print it on your own, definitely do that. If you see the 3D printer is not in use, rush in there and grab it. And then you have two more parts to design and turn in. I published them both today, and I'm hoping that this is okay with everyone. I would like to make the due date next Monday by midnight. That way, you still have that last week to get everything printed and put together. Um, so I know it's going to be a little bit crammed trying to do two parts in 1 week, but hopefully most of you have an idea of what you're going to design at this point, so it won't be quite as labor intensive uh, as it would have been at the beginning of the quarter. So, does anyone have any issues with that? Does that sound good to everybody? Yep. Um, all right. Cool. So, I think with that, I'm going to stop recording and streaming here. But I'll stay on the line so we can keep talking.